So in this video, we're going to talk about some commonly occurring limits for sequences. So I'm actually just going to jump right into them. I've got 6 of them to tell you about. So the first one is, so if I have the sequence, the natural log of n over n, so the limit of this as n goes to infinity will just equal 0. The next one is the limit as n approaches infinity of the nth root of n equals 1. The limit as n approaches infinity of x to the 1 over n equals 1. And this is for any value of x. So x is a number that you'll plug in. So x can be any number greater than 0 for this one. We have the limit as n approaches infinity of x to the n equals 0. So for this one, it has to be that the absolute value of x has to be a number less than 1. If it's a number greater than 1, then this is not true. Next, we have that the limit as n approaches infinity of 1 plus x over n to the n. This will always just equal e to the x, and this is true for any value of x. And then finally, the limit as n approaches infinity of x to the n over n factorial will equal 0 for any value of x. So these are commonly occurring limits that come up very often with sequences. So just to get you kind of used to using them, what we're going to do is we'll do a handful of exercises where we're just going to determine whether the following sequences converge, and if they do converge, what do they converge to? So for instance, if I'm out in the wild and I see a sub n equals -5 to the n over n factorial. So looking through this list that I have here, I can see that I have that -5 to the n over n factorial. So that's going to correspond with this particular limit here because it's allowed to be any x. So this tells me right away what my limit should equal. It should just equal 0. So, it fits the form of that. So I can just jump right to that is going to equal 0. Okay, now let's look at one where maybe it's not quite as obvious. So for this next one, so I have a sub n equals the nth root of 5 to the 2n plus 1. Okay, so the first thing that this feels like you need to do is first, I just want to kind of understand what's going on with the exponents and if I could maybe rewrite them in a more simpler way. So what I'm going to do is first I'm just going to explore this expression here. By rewriting this, instead of being an nth root, I'm just going to write all of this to the 1 over n. And from here, now I can recall my exponent rules or properties, right? So I can take 2n plus 1 times 1 over n. And so what is that going to give me? That's going to give me 2n plus 1 over n, all of that over n. And from here, now I can break this up into 2 separate numbers, right? So I can break this up into 2n over n will just give me 2, and then the 1 over n. So this is equivalent to this, and I can now break up this 5 as 5 squared and 5 to the 1 over n. So I just broke this up into 2 separate expressions, or factors. Okay, so from here, now that I'm here, the reason why all of this matters is that it's now going to help me with how do I actually evaluate this? Because I only have the nth root of n. So from where we started, we did not have enough information. It didn't look like we had a limit that we could use. But now I have this 5 to the 1/n. So this is for any x greater than 0. So I have a 5 here. And I'm told now that this particular limit will equal 1. So this is the limit that I'm going to use. So now I've got the limit as n approaches infinity of 5 squared times 5 to the 1 over n. Well, 5 squared is just going to be 25, right? But then this limit here, 5 to the 1 over n, that equals 1. So I've got 25 times 1, and that'll equal 25. Okay, so let's take a look at another one now. So now I've got a sub n equals the natural log of n over n to the 1 over n. Okay, so for this one, when I set up the limit, so I don't have anything in this list about natural log over n to the 1 over n. So I do have something that looks like this, but I have the wrong n, right? Because my n has this n to the 1 over n. So instead what I'm going to do is I'm going to break this into 2 separate limits. I'm going to take the limit of the top versus the limit of the bottom, and now I can evaluate these separately. And the reason why this matters is, okay, so we'll deal with this one in a second. But this limit here now looks like one that we have in our list. So as I look through this list, so remember I have the nth root of n, so I have this limit here. So I know that I don't have an nth root, I have it as a rational exponent, but we know that they're equivalent to one another. So now I can go ahead and evaluate each part of this. So this part here I know is going to 1, but as n goes to infinity, what's going to happen to the natural log of n? Well, this is now going to end up going to, this goes to infinity and this goes to 1. So now that I have this infinity kind of over one thing, I know that the entire value of this limit actually is just going to end up equaling infinity. And so what can we say about this? We can say that this limit actually diverges. So this sequence diverges, sorry. Okay, so now let's keep going. So now I've got a sub n equals 1 minus 1 over n to the n. So looking through this list here, so this looks very similar to this limit here. I'm allowed to have any x. So the x that I have in this case is clearly a negative 1. That is how I got that minus sign there. So using that, I know that where I have my x here, I'm going to replace it here for my e to the x. So this particular limit will end up being e to the negative 1. Okay, and for my last one, I have a to the n equals 7 to the n over n factorial. So as I look through this list here, so this really mimics the last limit, in this case 7 to the n over n factorial. So I know then that this one is just going to equal 0. Okay, so that is just a quick overview of some commonly occurring limits that you can just bust out. So if that was helpful to you, consider hitting that like button, and otherwise, I will talk to you guys in another video. Ta-ta for now.